before the usage of the word containerization, all right, this terminology has been used in the shipping industry. Can you guys hear me, guys? Can you hear me? Confirm.
Yes, I can
Correct.
hear you.
So this concept, this word, all right, has heavily been used in the shipping industry when the because of the idea of shipping goods, because of the idea of shipping goods from one destination to the other. All right, shipping goods from one destination to the other. But before then, that the shipping industry was still was 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 not modernized. All right. So someone wants to ship a car, let's say car from the US to Nigeria. Let's say he wants to ship a car. There's a car. Okay. This is a car from the United States to Nigeria. I want to ship this car from US to Nigeria. On a ship, it was very difficult. Difficult in the sense that not that it was difficult, but it was too expensive. Because for you to ship only your car, only one car from US to Nigeria, you know what the cost will look like. You know, it means that you were hiring the whole ship. And on that ship, it's not going to be only your car. There will be other goods. There will be other goods that will want to be moved from US to Nigeria and other parts of the world. So this has been the culture. This has been the method of moving goods from USA to Nigeria until modernization came into the shipping industry. Until modernization came into the shipping industry, shipping organizations started what they call, okay, what if we pick these items that these people wants to send from US. So and these guys want to send from US. What if we pick them and package them in boxes? All right. What if we put all of these goods in boxes from US and package it like that and send it towards to Nigeria? That's okay. They now started designing boxes. All right. They decided to call that box container. So on this container, we're going to have Toby's car. We're going to have my own car. We're going to have Benga's car. We're going to have other goods. We're going to have other goods. And you're going to move all of these goods. Now, these goods are all in container. We're going to ship this good into this container into what? Nigeria. That was how the word container came into existence. It wasn't there before. It wasn't there. You know, goods were being shipped from US to Nigeria on an individual basis. If I want a car, I will call the car company in US, order for the car, and the car company is going to ship the car, all right, put the car on the ship from US to Nigeria. But the moment this industry became modernized, they came up with the concept of, okay, let's put the goods belonging to Mr. A, B, C, D into a box, into a bigger box. All right, arrange it and ship it together. And when it gets to Nigeria border, all right, marine board, whatsoever, everybody who has his goods will come and pick up his goods one after the other. So that was how the concept of container made the shipping industry to boom. The shipping industry became very, very huge with the concept of container. So in computing, okay, so this gave birth to containers in computers. In computing, this gave birth. So now, some set of developers, they came together, say, okay, so let's use the idea of containerization or containers in the shipping industry into computing, whereby we can actually, you know, put together developer code. Let me type this. We can put together developers code, code libraries, runtime, frameworks, etc. Images. We can package all of these things. We can package all of these things. Ordinarily, if I need to deploy developers code, I'll deploy it on a physical machine, a physical server, or a virtual server. And that is how computing has been earlier on. But now, they've gotten concepts from the shipping industry. So, okay, what if we put all of these together into a simple unit, a single unit, and call that unit a container? Let me use a paper box. So this now will now become this will now become, let me give it a nice border. Great. So this will now become a container where we have developers code, code libraries, runtimes, framework, images, etc., etc. This was how the word container was born in computing. The process of packaging, developers code libraries, runtimes, frameworks, etc. into a single unit is termed as containerization. Is termed as containerization. Is termed as containerization. All right. Now, they started creating runtimes. They started creating runtimes, technologies to actually containerize codes. Technology started emanating. They now started creating container runtimes, container engines that could run this setup. That was how container technologies like LXC, Linux containers, Linux containers was born. Guys like Docker was born. And today we have other modern container runtimes like Cryo, container runtime interface, objects. There are there are lots of technologies for creating containers. All right. So in today's course, in this journey, we would base our training on Docker. Why Docker? Because Docker is the most commonly used container runtime. So we'll base our lesson on what? Docker. Because Docker is the most commonly used container runtime, or you can call it container engine, right? So that is why we are using Docker. So let's go further. Let's check. Now, that was understanding the concept of containerization. All right. The idea was born out of the shipping industry. All right. Not until the shipping industry was modernized, they were doing shipping the conventional way of moving goods from one point to the other, until this guy became modernized. They now start putting all goods into a closet, and they call it container, right? Container. So now ship your goods as a container into what? Nigeria. That same idea was introduced in the realm of computing, where developers' codes, their libraries, their runtimes, their frameworks were all what? Packed together into a single unit. And they call it container. They call it the idea of containerization. Okay? So because of this idea, they now came up with different engines that could run the kind of setup they have in mind. They came up with Linux containers, Docker, Cryo, all right, Containerd. These guys are more modern. Containerd. All right. These are more based on Docker. All right. We're going to see all of these when we start the process. Then we are only we are singling Docker from that list. All right, because it's the most commonly used container runtime or container engine, right? Which is used to containerize any application, right? So the next item is the benefits and use cases of containerization, right? I have very few in my head, things like scalability, portability. These are the benefits, right? Scalable, it means you can scale it. It's scalable. Portable, you can run it on multiple operating systems, right? Or on multiple environments. You can build it in a different technology, and run it on multiple platforms, all right? So I'm going to leave us with a documentation that talks about but before I go into that, let's look at Google and talk about container concepts. Then I think I have a better image for that to explain containerization, right? Understanding containerization concepts. Understanding containerization concepts. I think I have an image for that guy. Yes. Now, these, let me, you can see the idea here. Containers and containerization, a beginner's guide, all right? This is the idea, all right? What containers are, how they work. Okay, this guy is not giving us more of um computing yet. All right, files, libraries, environment variables. Okay. Now these are the let's look at the concepts. Let me see. No, this guy has gone deep. Okay. So let me copy this image. Copy this image. Oh, account storage limits. All right. So let me explain here. All right. So the concepts, all right, the idea is for it to be used in a multi-cloud environment, all right. It supports multi-cloud environment supports containerization, all right. Testing and continuous deployment, you can use it there. They need it there. In version control, you can see containerization. In isolation, all right, where it isolates the underlying operating system, all right, from itself, you see there. Security uses containerization. Resource friendly, is portable, it reproduces easily, can be easily be reproduced. You can destroy it at any time, right? You don't have any fear of losing anything because you can always create another container. Then in the practice of DevOps, container is highly used in that environment, right? So that is the concept, right? All right. The concept of understanding the concept of containerization, right? But if you're asked in an interview, what do you understand by containerization? This is what you tell them. Containerization is a process of packaging developers' code libraries, runtimes, frameworks, etc., into a single unit, right? Into a single unit. So that is containerization. Environment variables, right? Great. So now, benefits and use cases of containerization. Like I said, I have a link I'm going to share with us, all right? So please, what are the advantages and benefits of containerization? It is portable, it has speed, it is lightweight, it is lighter than traditional virtual machine. It is scalable, it is agile, all right? It is efficient, it is fault isolation, it provides security, somehow secure. There is ease of management, there's continuity, it's developer friendly, right? Now, you can also look at the disadvantages. It talks about security, orchestration, data storage, monitoring, right? Where would containerization be beneficial in an enterprise environment? So you're going to read a lot. Now, they now give what is Docker containerization, right? They talk about containerization versus virtualization, right? So I'll leave this document with us for us to read. Let me share it on please guys take note to read. Oh, very important, very, very important. Doc containerization. All right. Okay. So I'll share the document with us so I can close this guy out from my page. And okay. Now, let's now talk about comparison of containers and virtual machines. Like from this whole explanation, all right, there was a time virtualization was the buzzword. Virtualization, virtualization was a buzzword in computing. So virtualization is a process of dividing your hardwares, right? Creating other hardware out of your physical hardware. Now, you have a physical hardware. Physical hardware. Why is this color just... Now you have a physical hardware. From this physical hardware, you want to create other hardwares. All right? Other hardwares that is going to emulate. Okay? That's going to what? Emulate your physical hardware. So you call that, let me look for. So this guy now is going to emulate your physical hardware, all right? They will give it a technical term called virtual hardware. So it means that if I have storage, sorry, if I have storage, I'm going to virtualize my storage. I'll virtualize my network. I'll virtualize my CPU. I'll virtualize my memory. So things I'm going to virtualize my storage, CPU, memory, network. Okay, so these are the guys I'm going to virtualize. And on this side, it is stamped as physical hardwares. On here, it is stamped and known as physical hardwares. All right. But the moment it gets, physical. But the moment all these gets into this area, it now becomes virtual. It now becomes what? Virtual storage, virtual CPU, virtual memory, virtual network. So this is the idea, all right? Idea behind virtualization. So now, that's okay. Let's try to compare. Let's compare containers and virtual machines and look at what the differences, all right? So let's hop onto Google one more time. You can see difference between containers and virtual machine. Let's check. Now, look at what this definition says. Containers virtualize the operating system so the application can run independently on any platform. Independently on any platform. I think this should be the best definition so far between containers and virtual machine, right? While virtual machines go beyond that to virtualize physical machines so you can use your hardware resources efficiently. You can use your hardware resources efficiently. Here's a guy. So yeah. So with the idea of virtualization, I am efficiently using my hardware, right? So let's look at a proper difference. I will be using an image, all right, and a pictorial explanation to show us the difference. And this is what you will do going forward. All right. This image should be in your head. It's either in your head or it will, well, let me copy. Why now? Why? All right, let's continue. Let me. All right. I don't know if you're seeing these parts. Okay. Now, you can see virtual machines, and let me just open it from the location. Okay. Now you could see virtual machines and containers. Let's talk about the differences one after the other. Now, in the area of virtual machine, you have your storage, you have your infrastructure. So this is your infrastructure, right? Now, on top of your infrastructure, on top of the infrastructure, you have a technological hypervisor. Hypervisor is responsible for virtualizing your infrastructure. So the hypervisor virtualizes the underlying operating system, the underlying guest OS. On top of the guest OS, you'll be installing your binaries and libraries needed to install your running application. Now, this guest OS could be any operating system. It could be Linux, it could be Mac OS, it could be Windows, you name it. All right? So this hypervisor virtualizes, all right, the operating system. Okay? Now, on the hypervisor, there's something called virtual manager. The virtual manager is responsible for managing the different virtual machines. All right? So these virtual machines has their corresponding guest OS, guest operating system. So this app 1 runs on virtual machine 1, app 2 runs on virtual machine 2, app 3 runs on virtual machine 3, and so on and so forth. Now, on the other side, which is containers, you have your underlying infrastructure. On your underlying infrastructure comes your operating system. On the operating system, you have what we call the container engine. On the container engine, you now have what we call different containers. So now, what's happening here? Let me just give you an instance. I've not logged into my now. I've created a virtual machine that was as an instance on Amazon. Let me connect to this instance. Let me show you something. Copy. See. Now, this cloud platform is acting as my hardware. So this is my infrastructure, right? On this infrastructure, I've created my operating system, which is running on this EC2 instance. So my operating system is running on this EC2 instance. All right, great. Now, on this operating system, I want to install a container runtime, or a container engine. So in here, I'll install Docker. So Docker will be the de facto container engine in my environment. Now on Docker, I'll now start creating what? Containers. Every container is going to have their binaries and libraries. Container 1, container 2, container 3. They're going to have their what? Separate binaries. Now, the major difference between virtualization and containerization is that virtualization uses a technology called hypervisor, of which is not found in containers. All right. Now, each virtual machines on virtualization runs their corresponding guest operating system. For containers, the containers runs on the underlying operating system. So here is the underlying operating system. So this is the reason why I say the best way to tell the difference between virtual machine and containers is with this diagram. All right, with this diagram. The link I've shared with you, go through that link, read it up, all right, and you will get a proper difference between a VM and a container. 80%, there is 80% chances that you could be asked the difference between virtual machine and container in an interview. All right, in an interview. So that is it, guys. So let's check back on our course model 1. So the next on our list will be what? Introduction to Docker and its ecosystem. Right? So Docker, like I earlier mentioned, will be the de facto container engine that we will learn in our journey in this course. All right. So I'll leave the installation of Docker in module 2. All right. So we shall when we meet tomorrow, by God's grace, we shall talk about getting started with Docker, right? So we will do a lot of interesting things. Those things that you think, that you feel you can achieve with an ordinary machine, a physical machine, you can actually achieve those things running Docker. All right, running Docker. All right, so when we come tomorrow, we shall talk about Docker, talk about concepts in Docker. We shall start hearing things like images, creating images. From image, we create a container. All right, yeah. So without saying too much, is there any query? Is there any query, any doubts, anything we need to talk about?
Just a quick question, please.
Yeah, man.
Yeah, it has to do with the previous topic we did.
Okay.
I was trying to run a command, and for some reason I realized that the git checkout, you said git branch or git branch, yeah, will create a new branch, right?
No, Git branch will display the branches. Git branch will display branches.
Okay, to show you the total amount of branches you have.
Yes. Yes.
Okay, well, I tried running a program. I did git checkout -b, and then I put a branch name. And then he actually created a branch and
And
displayed.
check out and switch.
Yes.
Yes.
Okay. I was a bit confused because,
Okay. So
yeah, I just wanted to verify.
yeah, for the sake of others, all right. Let me thank you for bringing that up. Sudo yum install git. So I didn't mention that this flag. Right. So this flag wasn't mentioned. Okay. So mkdir repo. So go into repo, git init. All right. Now I need to create a branch. Git branch master. Sorry. Oh, I don't understand. Git branch name now. Not a valid object name. Wait. Okay, I've not created a file. Touch finance.txt, git add, git commits. All right. Now git branch. Okay. Now git branch dev, git branch staging. Now, if you can see git branch, I am currently on what? Master. So if I need to create a branch and switch into that branch, I'll say git branch -b, right? Let me call it QA, right? So now
I thought it was checkout.
it's supposed to wait, let me check that flag. Let me check that flag. See, copy a branch. They come branch supposed done too. They come branch supposed to do that stuff. But check out will do it. Git checkout -b. All right. QA. So now this guy creates this branch, right? And check that branch. So if I say git branch, I should see current on QA. All right.
Okay. Okay.
Yeah.
Okay.
Mm. So any other query, guys?
No, no problem. Thank you.
All right, no wala. So we meet tomorrow. All right. Until then, I'll say bye-bye and good night. Good night.